Today I will talk about introduction about electric circuit. Electric circuits are common and practical example of how ordinary differential equations are used in real life. In many electrical systems, the current and voltage do not change instantly but vary over time. Components such as resistor, capacitor, and inductor affect how this change happen, and their behavior can be described using differential equation. In this topic, ordinary differential equation help us understand how electricity works, especially in simple circuit like RC and RL circuit. By solving this equation, we can see how current and voltage respond when a circuit is switched on or off. This makes it easier to make mathematical concept with real electrical application.
So for our first problem statement in RL circuit topic is sound like a series RL circuit with a resistance R equal to 40 and inductance L equal to 8 henries is connected to a constant voltage source of V equal to 80 volt. The switch is closed at time t equal to 0. So our problem is to find the equation for the current IT. Second, the current at t equal to 0.5 second. Third, to find the expressions for the voltage across the resistor VR and the inductor VL. And the last one, to find the time when VR equal to VL. So for the calculation to find the equation for the current IT, we will list down first the variable and its value. So R is 40 ohm, L is 8 henries, V is 80 volt. Then we have to use the formula. The formula is 1 equal to V over R multiplied by in bracket 1 minus exponent power by R over L in bracket multiplied by T. Then we substitute the value given. Then for the last answer we will get IT equal to 2 multiplied by in bracket 1 minus exponent power by negative 5t m. For the next calculation, to find the current at t equal to 0.5 second, we will use the equation that we have found at previous question. So from that, we just have to substitute t equal to 0.5 second in t value. Then for the last answer, after we do the calculation, we will get 1.84 m. And then for the calculation to find the expressions for VR and VL, VR is equal to I multiplied by R. So I, we can take from the answer we get from the first question. Then we just multiply by 40. Then we will get the last answer for VR is 80 multiplied by in bracket 1 minus exponent power by negative 5t volt. Then to find the expression for VL, we will do the L multiplied by di over dt. Then we do the differentiation and calculation. Then the last answer is 80 exponent power by negative 5t volt. Then for the last calculation to find the time when VR equal to VL, we will take the expressions that we have found from previous questions. Then we will list the expressions for VR equal to the expressions for VL. Then we will do the calculation. Then we will get the final answer is t equal to 0.139 second.
We move to the next section, which is a problem statement 2 involving a RC circuit. So the problem is a RC series circuit consists of a resistor and a capacitor connected to a constant voltage source. Suppose the resistance is 8 ohms, the capacitance is 0.04 farads, and a constant voltage of 40 volt is applied to the circuit. Assume that there is no initial charge on the capacitor. The problem asks us to find first the charge QT on the capacitor at time t, and second, the current IT flowing in the circuit at time t. So how do we solve the problem? The first step, we have to rewrite the information that we get from the problem or question earlier. We have resistance, we have capacitance, and we have ET. So by applying Kirchhoff's law, we can solve this problem by using the formula R dq over dt plus Q over C equal to ET. We just substitute the information that we have and we get the result of dq over dt plus 25 over 8q equal to 5. We label this equation as A. From this equation, we can find the Px. This Px, 25 over 8, we used to find the integrating factor, which is we get integrating factor equal to exponent 25 over 8t. The next step, we multiply integrating factor with equation A. Then integrate both sides of it. We get the result Qt equal to 8 over 5 plus C exponent power of negative 25 over 8t. Next, how do we solve the second question? Remember that it's mentioned in the question, initially the capacitor has no charge, or Q0 equal to 0. So we can find C using the earlier equation we found at first question. So C equal to negative 8 over 5. And this C value, we substitute it back in the equation that we found at first question. And we factorize the equation. So by using the current formula, IT equal to D over dt bracket Q bracket T. So we can find the IT value by substitute the QT that we get earlier, and the final answer will be IT equal to 5 exponent power of negative 25 over 8t.
In conclusion, using ordinary differential equation help us clearly understand how an electrical circuit behave over time. It shows how voltage and current respond when the circuit is switched on, how they eventually settle into a stable condition. This method makes it easier to see the effect of each component such as resistor, capacitor and inductor on the circuit overall performance. Overall, ODE analysis is a simple and reliable way to explain and predict how real circuit work in practice.